Okay, we're now looking at page 6. So we're going to work through the next 6 or 7 pages or so. So I'm going to do these for you. So we're going to open up about 5 or 6 graphs, and you're going to fill in here. So this will be the first curve. You'll see the gradient of the tangent and the secant on the graph that I show you, and then you'll be filling this in. As point B approaches point A, you'll fill this in. We're going to do this for a second graph as well, so we're doing it for 5 or 6 graphs, okay? Called tangent secant 1. So what I'm going to do, you can see the gradient of the secant here is the red one. You can see it's quite different, and the tangent is in green. All right, so I've drawn the tangent to the curve in green and the secant is in red. So as I shorten the secant, this automatically works out its gradient. You can see that's steeper than what this would be. Look, if I move that around there, isn't that a negative gradient? Can you see? Look here, that's a 0 gradient, right? And as I move this around, I've got a positive gradient. So if I move B directly above A, then the gradient of my secant is 2. Now, let's look at, I'm going to zoom in on this line and look at the gradient of the line. That's a nice point there, and so's that, right? What's the gradient of the line? 2 over what? I've got, all right, let's do the gradient of the line here from these 2 points. Rise 2, run 1. What's the gradient of the tangent, the green line? 2. So look at the gradient of the secant. Gradient of the secant here was 3.56. It's coming down closer to 2, closer to 2. When A sits exactly on top of B, the gradient of the secant, and I lose it, is 2. Okay? It'll be 2, which is the gradient of the straight, which is actually ends up being the gradient of the tangent. Do you see? Well, because it's sitting. Isn't this getting closer and closer to, it sits on it. Now, see, the red thing was working out the gradient of the tangent, of the secant. So you can do the gradient from any 2 points on the line. Can you see those red bits? So see how that's steeper? Look, the gradient's coming down. That's flatter, flatter. Now, once this bit of the red line sits exactly on top of the green, I'm actually working out the gradient of the tangent now. In other words, the gradient of the tangent at that point is 2. The gradient of the curve is 2 at that point. No? Yes? So on your booklet, it says as the gradient of the secant approaches the value of what? What does it approach the value of? 2. Approaches the value of 2, therefore the gradient of the tangent equals 2. Okay? Next one. Got the gradient of the tangent and the gradient of the secant being worked out at the 1 point. Okay? So let's say on your graph, yes, B is down here. So can you see the gradient of the tangent is 1.41 at that point? It works it out. I've programmed it to work it out. Gradient of the secant here is approaching 1 point. Well, it's approaching the gradient of the tangent, which is 1.41. So just put 1.4 to 1 decimal place, okay? So can you see as B gets closer and closer to A that the gradient of the secant approaches the gradient of the tangent, okay? Can you see that? So in graph number 2, activity 2, the gradient of the secant approaches the value of 1.4, therefore the gradient of the tangent is 1.4. Got it? I've got the gradient of the tangent at A. Look, I can move A. I can move A to wherever I want. I can make it a nice number. We'll try and make it a nice number. Let's make it -2. That'll do. Close enough. -2. So at the moment, look, the gradient of the secant, as I move B closer and closer to A, the gradient of the secant approaches the gradient of the tangent, which is -2.
What if you make it on both?
I can move A wherever I want. Look, it's 5.84. All right, gradient of the tangent, let's get a nice value. Is 3 there? Let's bring B closer and closer. Gradient of the secant is 3.
I know it was intersecting at 2.24.
it doesn't matter where it is. The gradient, as soon as the secant gets closer and closer to the gradient of the tangent, I don't know, what, like here, if I put it on this side.
Yeah, like this.
Right, that's 2 point, let's say it's -2, right? Right, here, well, here the gradient of the secant's positive because that's a positive gradient. Here the gradient of the secant's negative, right? But as B moves closer and closer to A, see how the red thing's about to go onto the other green line, the red line? So now the red line will be sitting exactly on top of the green line. The red, that straight, that bit, right?
Put it on the other ways.
No, it won't work the other way. Well, it sort of could. You could bring it this way as well. But once A is on top of B, the gradient of the secant equals the gradient of the tangent. Okay? All right, so what does our one approach? So the gradient approaches the value of, it doesn't matter, on our one it was -2. So the gradient of the secant approaches the value of -2, therefore the gradient of the tangent is -2. Example for activity 5, this is activity 5, not 4. Gradient of the tangent, I can make it a nice number. I might make it 3 or something. I'll move it down here. So notice the gradient, oh, you know how we were saying 0 gradient? See, that's a 0 gradient, roughly. Yeah, that's a negative gradient. See the green one? Negative gradient, positive gradient. What's the gradient up here? Yeah, it is, if I can get it there. Too hard. So I'm going to make a positive gradient of about 3. Oh, let's make it whatever, it doesn't matter. 3. I'll put it up here somewhere. There. I might 3.3. Bit hard, isn't it? Here we go. There. Gradient 3, that'll do. All right, gradient of secant is 1.4. As B gets closer to the A, the gradient is the same, 2.99. We're going to make it 3, all right? So we're making it 3. That doesn't relate to your graph that you can see. So the gradient of the secant approaches the value of, I'm just going to put 3. Therefore, the gradient of the tangent is 3 using what I just did, not what's on your page, all right? But it is the same curve. 6, so I've got the tangent at A, and if I move B and tangent to A, I might make it a nice value, about 5-ish. So the gradient of the tangent to A is 5. Now you could work that out by doing the gradient of the straight line, but this does it for you. The gradient of the secant approaches 5 as B gets closer to A. Got it? All good? So, see, we can work out the gradient of the secant, but we can't work out gradient of the tangent unless you had some really good... the reason we do the gradient of the secant is if you know the x value on the curve, you know the y value by plugging it into the function, all right? So this one, for activity 6, the gradient of the secant approaches the value of 5. So we want to write our answer in limit notation. I'm not doing that in limit notation yet. The gradient of the secant approaches the gradient of the tangent. So that's just writing that like that so far. Let's write that for now because I've changed the values from what you've got on the curve, all right? So we'll just write that at the moment. Calculating the gradient of the tangent using the idea of a limit. As Q here approaches P, the gradient of the secant PQ approaches the gradient of the tangent. We can write this as follows. As Q approaches P, the gradient of the secant approaches the gradient of the tangent. In other words, see how Q has an x value of x? So as that x value approaches A, do you get it? As the x value of Q, which is x, approaches the x value of P, which happens to be A. So we can write as x approaches A, the gradient of the secant approaches the gradient of the tangent. Do you get it? As the x value of Q approaches whatever the x value of A of P is, which is A. So as x gets closer and closer to, so this here is the point A function of A. And if I look at Q here, while Q is up there, this is the point x, and up here is function of x, or whatever that might be. So this is x function of x, but as q gets closer and closer, as x, this value of x gets closer to that value of a, the gradient of the secant approaches the gradient of the tangent. So this invokes the idea of a limit. Using limit notation, we can write this as the limit as x approaches a of the gradient of the secant equals the gradient of the tangent. Okay? So, in conclusion, to find the gradient of the tangent at x equals a, sorry, it's all blurry, all you have to do is find, in other words, to find the gradient of the tangent at x equals a, all we have to do is find the limit as x approaches a of the gradient of the secant, or the way we can do this is the limit as x approaches a. Now, function of x minus function of a, that's just y2 minus y1. And this x minus a is just x2 minus x1, where x2, y2, happens to be the point x function of x, right? And so that's just a gradient formula with a limit. Now, I'll explain. And where x1, y1 is the point a function of a. So what we're saying is, as x approaches, so this x minus a, just watching, now, when x approaches a, you'll get a minus a is 0. That's why it's a limit. You actually cannot divide by 0. So it's just the limit as x approaches a. We can't substitute x equals a in here because you get 0, right? So that's why it's a limit. So the gradient of the tangent is the limit as x approaches a of function of x minus function of a over x minus a, which happens just to be the gradient of the secant. And we're just looking as x, as this x gets closer and closer to a. All right? Now,